Hi guys, this video today is going to cover literal equations, and the setup is going to be a little bit different. I have several examples here. We're going to work through some examples together, and then the ones that I don't do, those will be the ones that you work on in class. So first of all, the word literal equations, do you know what the word literal means? And I'm not talking about like, oh, it was literally the hottest day ever. I'm talking about the actual word literal. Like think about the root, like literature, things like that. Literal means with letters. That's what literal means. So literal equations are equations that have a lot of letters in them. That's what it means. So let's take a look at these. These problems are not very complex, and some people like them more than regular equations because there's no numbers. You don't really need a calculator. You just kind of do the math there's just letters. Let's take a look. One strategy is whatever that you're asking to solve for, we might mark that, like put a box around it or something. So this first one says that the perimeter of a square is this equation, P equals 4 times S. And then in parentheses, what I'm asking you is to solve it for S. Because look at the instructions. Solve each literal equation below for the indicated variable. So we're going to solve this equation for S. If I'm solving it for S, what I want to do to start, and you don't have to do this on every single problem, but as we're starting out, I'm going to, is I'm going to put a box around that S. Okay, that was kind of messy, so I think I'm going to change it to highlight. Okay, so I changed it to a highlight. So S is what I'm going to solve for. That means I need to isolate that S and get it all by itself. Well, if I have 4 times S, then doesn't that mean I need to divide by 4? And so I leave my answer as P over 4 is equal to S, or S equals P over 4. In any case, I'm done with that problem. So that's the answer. Okay, let's look at a little bit more complicated one. It's not too much more complicated. I equals PRT, solve it for R. This is a simple interest problem. This is an equation that we'll learn later on in the semester, or probably second semester. That's an I for interest. So we're solving it for R. So we need to get rid of the P and the T. Notice those are both multiplication. We can divide by more than one variable at a time. So I can divide by both P and T at the same time. So my final answer is I over PT is equal to R, because this P canceled, this T canceled, and it left me with an R. Why don't you go ahead and write that in the margin, because that's kind of an important thing to remember, that you can divide by more than one letter at a time. Okay, this next problem, I'm going to skip number 3. I'm going to let you do number 3 here in just a minute, or actually tomorrow in class. So I'm going to go to number 4. So I'm solving for B, so I need to subtract A. And if you wanted to subtract C at the same time, you could do that. You could do it in 2 steps if you want, but you can also just do it in 1 step. Okay, so my A's cancel, my C's cancel. On the left-hand side, I have B is equal to 180 minus A minus C. Make sure you're getting those, the negatives need to stay with the letters. So I guess the order doesn't necessarily matter, but it has to be a negative A and it has to be a negative C. And so B, that would be, whatever angle that is angle B, is equal to 180 minus A minus C. Okay, so remember that we are doing the ones that I've circled here. The ones that I have not circled, those are the ones that you'll do in class tomorrow. If we want to solve for G, how are we going to do that? I'm going to take a couple of steps because this looks a little bit more complex than some of them. First thing is fractions. I just always think it's best to get rid of those fractions as soon as possible. Now, remember I'm solving for G, so I'm going to leave that there, but let's get rid of this fraction. So I'm going to multiply both sides times 2. So I get a 2s is equal to gt squared. I'm solving for G. So I'm going to keep my G where it is. I need to divide by t squared. And you can leave that t squared as a t squared. When you first see it, you might think you need to do a square root or something, but since we're solving for G, the t actually does not need to be square rooted. The G is fine as it is. Let's look at number 9 and 10. Number 9, we're finding the perimeter of a rectangle. We're solving for L. And so L is what we're solving for. I've highlighted that just to remind us. All right, there are several different operations going on here. And so over in the margin, I want to talk about something that I mentioned last time. And that is when you solve equations, you follow PEMDAS backwards. So in other words, you start with adding and subtracting, and then you go to multiplying and dividing, and then you go to exponents and parentheses. So we need to start with adding and subtracting. In other words, we need to subtract 2w from both sides. That has to be first because PEMDAS backwards says we have to add and subtract first. Now we're solving for L. Here's my L. I'm going to divide by 2. And there's actually 2 different ways you could write this answer. You could leave it. P minus 2w over 2 is equal to L. If you wanted to sort of divide that out, you could, and you could write your answer as P over 2 minus w is equal to L. And if you don't understand that step, don't worry. You can do it either way. There's nothing wrong with this answer at all. Just leave it like that. But some people just really want to divide it, and so this is what you would get if you divided it. All right, the next one is a little bit similar because we have adding and subtracting, and we've got some multiplying, but we also have a fraction. So I felt like that was a good one to look at because people are intimidated by fractions. Okay, PEMDAS backwards says start with adding and subtracting. So we're going to subtract the 32. We get f minus 2 is equal to 9/5 times c. Okay, at this point, we need to get rid of our fraction. And I have been saying to do that, let's just multiply by the denominator. Some people like to say multiply by the reciprocal. Sometimes reciprocal works better, sometimes denominator works better. I typically just stick with the denominator, but you can do the reciprocal on this one. So I'm going to multiply by 5 over 9. And so if you multiply by 5 over 9 on both sides, this 5/9 and this 9/5 cancel each other out, and they leave you with a c by itself. And that's what we were solving for. On the left-hand side, I would just leave it 5/9 times f minus 32. I would not distribute that. If you distribute that, you're going to get some crazy decimal over here, and we just don't want to do that. So let's just leave it as it is. Okay, once again, before we turn the page, if you have questions, make sure you are writing your questions in the margin so when we come to class tomorrow, you can ask those questions. But now let's turn the page. Okay, number 12. Let's look at the area of a trapezoid. 1/2 h times b plus b. We're solving it for lowercase b. Okay, we have been talking in the past couple of days about sometimes you don't distribute. This is a really good example of when you would not distribute. Look, if I distribute here, let's take a second to write this down. Don't distribute with multiple variables. If you were going to distribute this, you would get a mess. I mean, I'll write it out, but don't you write it out because we're just going to erase it. This is going to be 1/2 h times b plus 1/2 h times b, and you're supposed to solve it for the lowercase b. Well, how are you going to get that? Now you're going to subtract. It's a mess. Don't do that. It's just making your problem more complicated than it needs to be. Instead, let's do this thing that we've been talking about and get rid of what's out here first. And I always like to get rid of the fractions first. Let's multiply this side by 2 over 1 and multiply this side by 2 over 1, or just 2. So the 2 over 1 canceled with the 1/2. I still have an h, so I'm going to divide both sides by h. Okay, so I have 2a over h equals capital B plus lowercase b. I'm solving for lowercase b, so I need to get rid of that capital B. Now I'm going to come over here and write my answer where I have more space, because this answer is actually pretty important that you write it in the correct order. And what I mean by the correct order is you want your b to be over to the side. Your b is not part of the fraction. The 2a over h is the fraction, but then later you subtracted b, so it's not part of the fraction. It's like over to the side. In fact, if you wanted to put parentheses around it just to distinguish that, you could, but it's just really important that that b is not inside that fraction. But then we have solved for b. We're done. So it took a couple steps, but we got our b by itself. Okay, so that's how we solve literal equations. This is a really important skill in your science classes. I teach physics. We do this every day. It's just really important to be able to manipulate the equations and move things around. I want to take a look at some of the problems at the bottom of the page that look a little bit different. So number 18 says, a principal of $3,000 was invested in a savings account for 3 years. If the interest earned for the period was $450, what was the interest rate? See exercise 2. Let's look at exercise 2. Okay, exercise 2 has this formula, I equals P RT. It also has this formula that we figured out, R equals I over PT. Let's take a second to copy both those equations down on the other side of the paper so that we have them and we can decide which one to use. Okay, so the two equations again, I equals PRT or R equals I over PT. And in this, I stands for interest, and you don't have to write this down, but you can. So I is interest, P is the principal or the starting amount, R is the rate, the interest rate, and T is the time. Okay, if we read the question again, the final question is, what was the interest rate? So we are looking for the rate. Because of that, I'm going to use the second equation. Now, you could use the top equation. There's no reason not to. But the bottom equation is solved for the rate, and so let's use that one. Okay, so I'm going to plug in the I is the interest, and it says the interest earned for the period was $450, so that's going to be my I. The principal was $3,000, so that's my P. And the time is 3 years, so I'm going to plug that in there. So now, instead of having to rearrange my formula as I go, it's already been rearranged, and now I can just solve it. Okay, so now we're going to get out our calculator and take 450 divided by 9,000. And when I divide that out, I get 0.05. The question was, what is the interest rate? Interest rate is typically talked as a percent, and so 0.05 as a percent is I can change that over and make that 5.0%. Okay, remember that with percent, you move it over 2 places, and that's going to give you 5%. So this is a 5% interest rate. Okay, like I said, write questions down in the margins. This one I ran out of margin space, but there is some space up here that you could write down your questions. There are not summary lines, so you don't have to write a summary. If you wanted to, you certainly could write some things down at the bottom to remind yourself how to do some of this. But we will talk about this in class tomorrow, and we will finish up this worksheet. That'll be your in-class assignment tomorrow, just to finish this worksheet.